Hello everyone, welcome to the exercise solution video for Snap programming. So first of all, if you log into Blackboard, you should be able to see the Snap 1 material in the course content. So you need to download the first file and extract it to desktop, download it and then extract it to desktop. Once you do that, you will have this folder on the desktop, that is Snap 1. So make sure you have this folder. So once you open that folder, inside it we have the presentation and 3 other files. I will talk about them later, but inside the Snap, so the details of algorithm, once again, it is a set of well-defined instructions in a sequence to solve a problem. This part will be explained during the class. For now, we will focus on the exercise and what is Snap programming. So to do the programs, first of all, Snap is, once again, it is a programming language and it is used to implement algorithms. There are 2 ways you can open this programming environment. You can directly go to this website, snap.berkeley.edu, or you can Google Snap programming. If you forget the website name, just Google Snap programming and it will show you the first link, and if you click on this link, it will open the Snap programming environment. You click on the Run Snap button. So here we are. In the Snap programming environment, we have different sections that I will go through one by one. First, let me zoom in a little bit so you can see it clearly. Now, the top bar that you see here, that is called the toolbar. It has different buttons. I will talk about their use later on. On the left side, we have this bar which is called the palette area. In the palette area, we contain different groups. Each group contains different blocks which we can use to implement our algorithms. So we have the control group, we have the sensing group, operators, variables group, and so on. And how the Snap programming work is, we take these blocks out and we put them in this work area. This work area is basically called our scripting area or script area, which is shown here. So once again, this is the palette, this is the scripting area. This is where you will implement your algorithm. And how you will implement? You will just connect the blocks. For example, if I take one block from here and one block from here, and how to connect, we just place them close to each other and they will just snap together. They will just attach together. That's how the name Snap programming came. So this is how we will use these blocks. So this is the scripting area where we will implement our algorithm. Then on the right side, we have this white area that is called our stage. The stage area is where you will see the results, you will see the output of your algorithm, you will check the implementation if it is correct or not in the stage area. And in the stage area, we have this arrow shape object. This arrow shape is also called an object, or it has another name that is called turtle graphic. So let me write down the instruction. Wait. So I will write down some basic things that I will talk about here. So that arrow shape is called a object, or it is also called turtle graphic. So these are the names which are given to this object. And this object, this arrow shape, it can be controlled using the script that we provide here. So we can move this and we can do a lot of things with this object. So the script plus the object, the turtle graphic, together they are called a sprite. And a single snap project can have one or more sprites inside. So this bottom area that is under the stage, that area is basically called our sprite coral area. It shows you the different sprites which are available in our project. Right now this is our main stage project, and inside this we have just one sprite. If we have multiple sprites, they will be shown here, but the programs that we will do related to snap programming, we will have just simple single sprite. So let us begin now. The first algorithm that was given in the PowerPoint presentation, that was to calculate the average of two numbers. So this one is very simple. What you need to do is every algorithm must have a start point, it must have a stop point. Then we need variables. Variables are unknown quantities that we have in our algorithms. We do not know what the values of those unknown quantities are, so we represent them using variables. And when I say declare variable, that means reserve a space. In case of computer science, reserve a space for that variable in your computer's memory, and we give it a certain name. We can call it num1, we can call it num2 for the second number, and we can call it average for the average calculation. So I create three variables, two for the inputs and one for the output. When you are making algorithms, you have to be sure how many variables you need, how many inputs, how many outputs. And then you need to get the inputs. You need to get the input for the first number, you need to get the input for the second number. This is same like the calculator is asking you to give him the first number and the second number. Similarly, we need to write an algorithm in such a way that we can receive input from the user. Once we have the input, then we can calculate the average, which is equal to, very simple calculation, num1 plus num2 divided by 2. And after that, we can show the average, which is our output, show the average, and after that we can stop. So this is a very simple algorithm, but I will go through each step one by one and show it in the snap programming. So first of all, we have the start step. So start is in the control group. In the control group, we have the first block that says when green flag clicked. This block is used for starting algorithms. That means when green flag clicked means in the stage area there is a green flag button. If I click on that button, I should start my algorithm. So that's the purpose of the green flag. Then we need to declare, we need to create three variables. So to create variables, you can go to the variable group, click on make a variable, and then it will ask you what is the name. You can call it num1. Similarly, you can make a variable num2, make another variable called average. So I have three variables here now. So the next step is to input each variable, the input variables, each one of them I will input one by one. And how do we input? We ask to enter the first number for the first input, and what we will do is we will go to the sensing group. There is a block that is called ask. So I will take it out and place it near the green flag block, and you will see it will snap together, and I can change the message from here. From what's your name, I can say enter the first number and wait. So if I run this right now, what will happen in the stage when my algorithm runs, it will show you this result, enter the first number, and it is waiting for an input. So when I enter a number, let's say 13, this number is lost. You see the num1 and num2 variables, they don't get this number because this number is lost. So whenever we enter any number in the stage, in the output, this number goes to this block which is called the answer. and this answer should be given to num1 so that num1 can receive that number. To do that, I can go to variables and take out the set block. What the set block will do is I can say that set num1, the first number, to the answer. If I do that, what will happen? If I run it again, it says enter the first number. If I enter 13, let's say, now you see num1 variable will receive that number from the answer block. In similar way, you can right click the ask and say duplicate and place it under the set so that we can ask for the second number. And for the second number, the answer should go to num2. So in this way, I can receive input 1, num1 and num2, and then I can calculate the average. So that means when I'm calculating the average, I will say that set average not to the answer, but average should be set to this equation, num1 plus num2 divided by 2. To do that, I will go to the operator group. There is the addition block, I will take it out. There is the division. And how you connect these blocks will decide the order of the operations. There are no brackets in Snap programming. The order is decided based on how you attach these blocks together. If I put division inside addition, what will happen? The right side division is calculated first, then we add. This is wrong. I want to do addition first, then divided by 2. So whichever operation you want to do first, you use that and put it in the other operator. So now what will happen? You will see the addition block is in the front, the division is behind. That means addition will be done first, division will be done after that. So here I can put, once again, here you can type numbers 1, 2, 3, whatever you want, but you cannot type variables. You cannot say num1, num2 here. You have to use the blocks. So if I go to variables, you will see there is num1 and num2 blocks here. So I will say num1 plus num2 divided by 2. So this is our equation. Now I want to use it and set it to the average calculation. So what I can do is I can take it and place it for 0. But you have to be careful. When you move the equation, you always move using the block which is behind. You see, division block is behind. The addition block is in the front. If I move the equation from the addition block, it will just take out the addition block. I don't want that. I want to move the whole equation, so I will use the division block and then put it here. So I have calculated the average. The next step is to show the results. To show the results, we have the looks group, and there are different options here. I can say hello for 2 seconds or use the say hello block. It does not have any time limit. The time limit, normally we don't use it. We will use the 2-second block because later on when you study loops, it will be useful to use the per second block. We will see more about it later. But for now, just for the understanding, what we can do is we can say the say block. What it will do is it will say the text inside this box on the stage for 2 seconds. Let's change it to 3 seconds, or you can say 4 seconds. It's up to you. But I don't want to say the text. I want to display my average. So what I can do is I can go to variables and take out the average block and put it here. So now it will display the average. And the last step in an algorithm is to stop. To stop, I can go to the control group, scroll down. After the if-else blocks, there is a stop block. I can take the stop block here and change the option to this script. Why we are using this script? Because we have only one script. I told you in the beginning we can have multiple sprites, and their control we can stop multiple sprites by using stop all and so on. But for the basic programming, we will just say stop this script. So this is our complete package, first implementation of the average calculation algorithm. So if I run this now, it will say enter the first number. If I enter, let's say 15, and press enter, num1 variable will receive that number through the answer block. It will ask me for the second number. If I enter, let's say 13. Now I did not press enter, but I will show you when I press 13, the answer will go to num2. The average will be calculated and average will be shown after that. Let's see. If I press enter now, it shows the average, which is 14. It will display it for 4 seconds. After that, it will stop. So this is our very basic algorithm that we have. Now let me begin the exercise. Let me get rid of this and start our exercise. Our exercise first main program was related to this radius of a sphere. So in this program, what you need to do is you need to get input for the radius of a sphere, and then you need to calculate the area and volume of the sphere. The area calculation is given here, the volume calculation is given here. In this case, we have two outputs, area and volume, and we have one input. So I will write down the algorithm first once again. In this case, once again, we have the start point, we will have the stop point also. So after starting, we will declare now once again 3 variables, but this time there is one input and 2 outputs. So I will say declare variable called radius, area, and volume. So I have created 3 variables, 1 for the input, 2 for the output. The next step is to get the input. So input the variable that is radius. And how do we input? We will ask. We will say ask to, with this message, to enter radius. And when you enter the radius variable should receive the answer block. So this is how we will receive the input. And once we have the input, we can calculate the area. Area will be equal to 4 multiplied by pi, which is 3.14, multiplied by radius power 2. Sorry, not division. 4 pi r square, that is area. The volume will be equal to 4 divided by 3 multiplied by pi, which is 3.14, multiplied by radius power 3. So this is our area and volume calculation. Then I want to display the message that show on the screen that volume is equal to whatever the value you calculated, and then show the area is equal to whatever value we calculated, and after that we can stop. So to do this, I will start once again. So here is our snap window. I will start with the green flag. I need to declare 3 variables, radius, area, and volume. So I will go to variables, make variable called radius, make variable called area, make variable called volume. So I created 3 variables. Then I will input the radius. How to input? Ask. I will go to sensing, take out the ask block and change the message to enter radius. Whatever answer we receive, I need to set, I will go to variable and set the radius to that answer. After that, I need to calculate area and volume. That means I need 2 set blocks. Make sure you don't leave them here. You have to attach. Okay, see, I am attaching 2 set blocks here. So I will set area and volume to their equations. So I need to make this equation first. So area is 4 pi r square. That means I need 2 multipliers and 1 power. I will go to operators. I will take out 2 multipliers and 1 power. This is the power block. Now we need to make sure, let's say if I join the multipliers together, we need to make sure we do not put the multipliers inside the power. If I do that, what will happen? It will calculate the whole multiplication first and then take the power, which is not what I want. I want to calculate the radius square first. So what I do is I keep the multipliers aside. I will put the power inside the multiplication. So now you see the power will be calculated first. Then we can just put the values. So 4 multiplied by pi, which is 3.14, multiplied by radius power 2. And to move the whole equation, we use the multiplier which is behind and put it in place of area. Similarly, for the volume, we have 4 by 3 pi r cube. That means one divide, 2 multipliers, and 1 power. So 1 divide, 2 multipliers, and 1 power. So multiplication we can do together. This is okay. The main thing is we need to do the division separately. We cannot put multipliers inside the division. They must be on top. They must be on top, so that 4 by 3 is calculated first. Then the answer is multiplied by pi, which is 3.14. And then the answer is multiplied by radius power 3. And once again, we cannot put this multiplier inside radius because it will do the whole bracket. So the radius power should be in front. So I can put here radius power 3. So 4 by 3 multiplied by pi r cube, and we move the whole equation for the calculation of volume. So this is area and volume calculation. After that, I want to show the results. I will go to looks and use the 2 say blocks. But one more thing, let me complete it first. I go to control and use the stop block to stop this script. In the say now, in the display, I need 2 things. I need the text and then the value which is calculated. Text plus value. That means I need to write something like volume is equal to, and after that I need the value of the variable volume. To do that, if I go to variables and put the volume here, it will replace the text. So the say block by default, it cannot have both the text and variable together for the output. To do that, we have the operators group and we have a block called join. If I put join here, join can basically be used to connect text and variables together. In one box, I can type that volume is equal to, this will be a message on the stage. And on the second box, I can put the variable. So that means in the stage, it will display the text followed by the value inside the variable. Similarly, I can do it here. Let's make them for 3 seconds each. And this one is for area. And the message should be area is equal to the calculation. So here, if I run this now, it says enter radius. If I enter, let's say 4, it will show volume is 267.94, and then it will show the area, which is equal to 200.96. So this is your first program in the exercise. So what you need to do now is go to the desktop and make a new folder called snap1 minus your student ID, whatever your student ID is. Once you have that folder, what you will do is we will put all the programs that we do in this exercise in that folder. So how to do that? In the toolbar, we go to the file button. This is the file button. And do not click save, because the save will save the project on the cloud, on the website. We don't want that. I want to get the file out. So I will click on export project. It will ask me what is the name. You can call it Q1, the first question, and press OK. Then it will ask you where you want to save it. I can go to desktop, the folder I created, and inside I will save it. In some computers, it will not ask you where you want to save. It will just directly download the file. In that case, you can click on the small arrow, click on show in folder, and from there you can right click that file, cut, copy, and go to desktop snap one minus your ID and paste it here, but for me it's already here. So you have to put all the question files here and then submit the folder later. I will tell you how. So this is our first program. Let me make a new project now. So the second project is also very simple. The second one is to convert temperature from Celsius to Fahrenheit. I need to make a program for that. So that means I will have one input, that is the temperature in Celsius, and one output, that is the temperature in Fahrenheit. So I will have two variables, one for input, one for output. So let me begin again. I will start and I will declare two variables, that is, let's call them C and F. Let's make it simple, C and F. C for the Celsius, F for the Fahrenheit. I will input the Celsius temperature. And how do we input? We will ask to enter temperature in Celsius, and whatever answer we get, we will make sure that the C variable will get the answer. So once I receive the answer, I can calculate the Fahrenheit temperature, which is 9 by 5 multiplied the temperature in Celsius plus 32. But the division should be done first, followed by multiplication, and then addition should be at the end. After that, I can show the temperature in Fahrenheit and then stop. So this is a very simple algorithm that we have. Let us begin. I can go to control section, start with the green flag. I declare two variables. So I will go to variables, make a variable called C, make another variable called F, press OK. So I have two variables now. Then declare so I have created two variables. Then input the Celsius temperature. I will go to sensing. I will ask enter temperature in Celsius. Whatever answer I get, I will set Celsius to the answer, and after that I will calculate F. I will say that set F, the Fahrenheit temperature, to this equation. For this equation I need division, multiplication and addition. So I will go to operators, division, multiplication, addition. So once again, I want to divide first, then multiply, then add. So I will put division inside multiplication, and then I will put multiplication inside addition. So once again, this will be my equation 9 divided by 5 multiplied by the variable C plus 32, and I will move the whole equation from the block which is behind plus this one. After that, I can go to looks and say, let's say for 4 seconds, I want to display the message that Fahrenheit is equal to the value. I will go to operators. I will take out the join block, put it here, and I will say Fahrenheit, let's say temperature. You can display any message you want here, is equal to, in the second box, I can put the variable F, which I calculated, and after that I can stop this script. So if I run this now, once again, enter temperature in Celsius. Let's check for 37. It says the Fahrenheit temperature is 98.6, which is correct. So this is our second program. We repeat the same thing. I go to the file button, click on export project. I call it Q2, press OK, and I save it in the desktop snap one folder minus your ID folder and save it. And after that, I create another new project. Okay, for the third one, for the third project, we need to understand some operators first. So first of all, we have an operator called mod. What's the mod operator? It calculates the remainder after integer division. The remainder after integer division. Normally, let's say if I divide 7 by 3, I will get the answer 2.33, something like that, right? What is integer division? You should know this already. Let me show you here. If I have this, let's say, so what is integer division? We have, let's say, this is normally how you divide. So let's say if I have 7 here and I want to divide it by 3, so what we do is we say that 2 is our number, that is 6. 3 times 2 is 6, and then we have a remainder 7 minus 6. The answer is 7 minus 6. The answer is 1. So I'm left with 1. I cannot divide any further. This 1 is the remainder. This mod operator will give me, if I do 7 mod 3, it will give me the remainder, which is 1. More examples. If I do 25 mod 10, so 10 2s are 20. I cannot divide any further. So 25 minus 20 is 5. I'm left with the remainder 5. 25 mod 7. 7 3s are 21. I cannot divide any further. The remainder is 4. So this is how the remainder, the mod operator works. Another operator we have is what we call floor. Floor and ceiling. Both of these functions, they work on real numbers, and what they will do is, floor function, it converts a real number to the previous integer. So once again, floor converts a real number to the previous integer, and the ceiling will do the opposite. It will convert a real number to the next integer that is after the real number. For example, if I have input, let's say my input number is, let me write it down here. Let's say my input number is 42.34. So floor function will convert it to the previous integer, that is 42. The ceiling will convert 42.34 into the next integer, which is 43. Okay, another example. If I have a number that is, let's say, 4.94, floor will convert it to the previous integer, which is 4. Ceiling will convert it to 5. So this is how floor and ceiling works. Advantage of floor is, let's say I divide some numbers. Let's say I divide 7 by 3, I get 2.33 answer. I want to remove the decimal part. I want to get 2 out. What I can do is I can take the floor. So floor function is very useful. We will see this also later. The last type we have is what we call a round function. The round function converts a real number to the nearest integer. Nearest integer means whichever integer is closer to that real number. For example, round of, let's say, 4.9 will become 5. Similarly, round of 4.1, since it is closer to 4, it will become 4. So this is the round function. Most important ones are floor and the mod operators. We will use them a lot. So let's check how we can use them in our third question. So this was the detail. It is given here. You can check it. Now, in this program, we want to read a number of days, then compute and display the equivalent number of weeks and days. So this program, how it works is, You can think of it like asking someone how many days you worked at a certain place. You can say, okay, enter total number of days you worked. Let's say the user types 26. Then my program should display, okay, that you worked for 3 weeks and 5 days. How can I get the 3 and 5 from an input number like that? So this is our main idea of the program. So how the structure of the program is, we follow the same procedure. We write the pseudocode of the algorithm first. We start and we declare variables, and this time we have one input variable, the total number of days, and two outputs, that is weeks and days. So I will say declare variable, let's call it total, and then weeks and days. So I have three variables, total the input, weeks and days the output. After that I can input the total number of days. And how do we input? The same thing, we say ask enter total number of days, and whatever answer we get, I will set total to the answer. So once I receive the input, I will calculate the weeks, I will calculate the days by some equation we need to find out. After that I can display, I can show that weeks is equal to some value which we calculate, and days is equal to the value for days which we calculate, and after that we stop. So how to calculate weeks and days? The days part is very easy. So there are 7 days in a week. So to get the 5 out from 26, we can simply take the number, whatever total number of days are, we can say total mod 7. For example, if total is 26, 26 mod 7, 7 3 is a 21, and the remainder is 5. So I can get the days part out by this equation, that is total mod 7. As for the weeks, I need to get the 3, for example, the 3 part out. So how to get that? We have the example. If I divide 26 by 7, divide, the proper division, not the remainder or anything. If I divide 26 by 7, what do I get? Let's say 26 divided by 7, I get 3.71. I get 3.71. I want to remove the point part so I can get the weeks, the 3 value out. To remove the point, the decimal part, I showed you, we can use the floor function. So that means if I take the floor of this thing, it will give me the answer 3. And if here, instead of 26, I can have any number of days, the total number of days, whatever we entered. If we divide it by 7 and then take the floor, we will get the answer of weeks. So my weeks is equal to floor of, here, floor of total divided by 7. So let us implement this now. So have the start point, green flag clicked. We declare variables, total, weeks and days. I go to variables, make variable total, make variable weeks, make variable days, and then we input. I go to sensing, I ask to enter total number of days, and whatever answer I get, I will set total to the answer. So I receive the input. Now weeks and days calculation. So I will say set, I will take out 2 sets, one for the weeks, one for the days. Days was very easy. I go to operators, there is already a mod block. So I simply say the total mod 7 that will give me the days part, total mod 7. The weeks is floor of total divided by 7. So I go to operators, I take out the division. Now I need to take the floor. The floor functions, they are available in this group, that is the square root of 10. I can change the square root to absolute, negative, ceiling, floor. You see here is the floor. I can have other options, square root, sine, cosine, that we can use if you need. Right now I need the floor. I will change it to floor, take it out, and once again, do not put floor inside the division. This is wrong. I need to divide first. So I will put division inside floor and then take the floor. So floor of total divided by 7, that will give me weeks. And then the rest is easy. Let's write the whole output in one say block. Let's say for 4 seconds. And use the join. Here is the join. And now for the output, I want to join these 4 things: the text, the value of weeks, another text, and the value of days. So that means I need 4 boxes: text, variable, text, variable. Right now I have 2. I can add more using the right arrow, another one. So I have 4 boxes. So first box, weeks is equal to, in the second box I put the value of variable weeks here. In the third box I type days is equal to, in the fourth box I put the variable days, and after that I can stop this script. So this is our third program. If I run this now, it says enter total number of days. Let's check it for this 26. I should get 3 week 5 days. Let's see. So enter total number of days. If I enter 26, it says weeks is equal to 3, days is equal to 5. Let's run it again for some other number. Let's enter 745. It says 106 weeks and days is equal to 3. You can even modify this program to display years, weeks, and days. Think about it, how you can do that. I will leave that to you. So now, export this project again, call it Q3, press OK, and save it in the same folder. And then make a new project. You press yes. Now, what is the last project here? So the last project here is this one. Write a snap project that will display the result of the following equation. So when you have a complex equation like this, and it says you have to ask the user to enter the value of x. This one I will just do it directly. Let's say the output of this equation I will save in the variable y. I can say y is equal to this result. So now I need 2 variables, input and output variables, that is x and y. So I'll start and make variable called x. Make another variable called y. And then from sensing I can ask enter x. Whatever answer I get, the same thing, I will set x to the answer, and after that I can set y to this equation. But this equation is complex, so we divide it into separate parts. Let's calculate the first part. I need these vertical bars, they are the absolute function, so they are in operators. I can change square root to ABS, that is absolute. Absolute I want to do at the end, but first I want to do -3 separate. I want to do 2 cube multiplied by x separate, then add them and then take the absolute. So first let's do -3. For -3 there is also the block here that you can change to neg, that will negate, and you can put a number here 3. So -3 2 cube multiplied by x. Power, that is the cube, I will put multiplied by x. Once again, I will put cube on top and I will say 2 power 3 multiplied by x. So this is the right side of addition, this is the left side. Between them we put a addition. So left side is negative 3, right side is 2 cube x, and this whole thing I have to put it inside the absolute. So absolute of negative 3 plus 2 cube x. This is the left side. The right side is 1 divided by, so I will take out the division. I will say 1 divided by cosine. So I will change this negative to cosine and put it in the bottom. So 1 divided by cosine of, now inside the cosine I need to do this calculation separate. 7 plus 3x. That means 3x should be done first, then added to 7. So multiplication should be inside the addition, so multiplication will be done first. So 7 plus 3 multiplied by the variable x, and the whole equation I will put here like this, and this is the left side, this is the right side. Between them we have addition, so I take addition out. The left side is the absolute. Make sure you put it in the right box. You see, it will show you different options. Don't put it in the wrong place. You have to put it on the left side of addition like this. Move the addition down. This equation should be on the right side like this, and the whole equation should be value of y, and after that I can just display the value of y for, let's say, 4 seconds. I can go to operators, I can join, I can say that y or output is equal to the value of variable y, and then the same procedure we can stop this script. If you run this, you should enter x. Let me enter 4. I will get the answer 30.057. So that is your program. If I go to file, export project, call it Q4, I can put it in that folder as well. So the exercise, you need to do these 4 questions at least. Then the next are for practice. So this one, we just want to check the output. We have 3 variables A, B and C. So let us follow the sequence. I will follow the sequence with you. So we have, let me do it here. So we have 3 variables A, B and C. A is set to 8. So the value of A is 8, B is 12, C is 5, and we follow step by step. This type of question can be asked in the quiz. So step 4 says change B by -3. Remember, it is change, it is not set. Change will add or subtract to the current value of B. Current value of B is 12. And when we subtract 3 from it, that is minus here, you see. That means subtract B -3 from the current value of B. So 12 minus 3, B will become 9. Then set A to A plus B. So A right now is 8, B is 9. 9 plus 8, 17 is the new value of A. So A will become 17. Then set C to A multiplied by C minus B. Here you can see the C minus B block is in the front. So C minus B, that means 5 minus 9 minus 4 multiplied by A. Minus 4 multiplied by 17. Sorry, not 16. So minus, did I make a mistake? Yeah, okay. So minus 4 multiplied by 17. So you should get, I think, 68. 7, 4, 28, 8, 2, yeah. So you will get the answer minus 68, and this minus 68 is the new value of C. So I will set here minus 68, and then I can show A, B and C. So the output of this will be A is equal to 17, B is equal to 9, and C is equal to minus 68. What about this one? What will be the mathematical equation of the following? So here you see, you just follow which block is in the front and then you keep moving back step by step. So you see e power a is in the front. So e power a is calculated first. Then we take the sign of it. So I will say sine of e power a. And sine is in the denominator of a plus b. That means a plus b divided by the sine, like this. So a plus b is the numerator, sine is in the denominator, and square root of this. That means calculate the square root of this whole thing, a plus b over sine of e power a. And the whole square root is in the power of 10. So that means this whole thing is in the power of 10. 10 power square root of a plus b over sine of e to the power a. You can see this result here, that is 10 to the power square root symbol a plus b divided by sine of e to the power a. And here you see I can give you multiple options. The correct option will be a is 17, b is 9, c minus 68. That will be this option. For more practice, you can try and try to write these equations in Snap as well. So what you will do is, let me do this one a little quickly. So you don't need to submit those equations, just practice on them. So here we have these equations. So let me make a new project. So here, that means here I have two inputs, x and y. So I will start, I will have variables, x, variable, y. And just like before, you can ask for x and y input. I will not do that part right now. I will just do the operations. So 2 multiplied by x plus y divided by 2, that is 2 multiplied by x plus y divided by 2. Y divided by 2, I will do it separately. Y divided by 2 and then add. Left side of add should be 2x, right side should be y divided by 2. So like this is the equation. For this one I need a, b variables. So let's say I have variables a, variable a and variable b. So here I will do a plus b first, a minus b, and then divide and then square root. So a plus b, a minus b, I need division, and then I need square root. So let's do them one by one. So a plus b I will do separate, a minus b I will do separate. A plus b is in the numerator, I will put it in the numerator. A minus b is in the denominator, I will put it there. And the whole thing is inside the square root, so I will put it inside the square root. So this is how you can do the second one. Third one, b plus xy over c plus d plus 2. So this is interesting. So we need c and d also. So let's make variable c, make variable d. Once again, you have to ask for inputs. I will not go that part. I will just do the equation part here. Let me increase the size. So here, so once again, we have b plus. So b plus should have this whole equation, that is x multiplied by y, x multiplied by y divided by x, y should be in the numerator, divided by what? C plus d. So I will put it here, and variable should be c plus d, and this whole thing xy divided by c plus d, this should be on the right side of addition. And then we need another addition. So the left side of this addition should be this b plus xy over cd. I will put it on the left side. Then the right side should be 2. So very simple. This should be the value of a. Then the last one is to read three coefficients of a quadratic equation, that is a, b and c, and then calculate the discriminant. It's very simple program. You can, let's keep this equation aside. You need to read three coefficients of a quadratic equation. So we already have a, b, c. So let's say I will simply ask to enter a. Whatever answer I get, I will set a to the answer. Then I can duplicate this and I can say enter b and set b to the answer. Duplicate again. I can ask to enter c and set c to the answer. I got the three inputs. I will calculate the discriminant, which is d. Very simple equation. B square minus 4ac. So b square I will do by power. Minus is minus. 4 multiplied by ac, that means I need 2 multiplication. So here I combine them. That will be 4 multiplied by a multiplied by c, and here I will have b square, b power 2, not 21, b power 2. So b square minus 4ac. So b square on the left minus 4ac on the right, and that is determinant. After that you can show and stop. So this is more practice for SNAP. Last thing is a very simple car program that we have. We just want you to check how it works. So one more thing is these programs, if you, let's say this is our programs that we did, if I open them, let's say I open them in Google Chrome, it will show you the code. You cannot open them directly. To open them you have to go to the file button and import. If I import, if you want to check if there is some mistake or anything, you can open, let's say Q2, it will import this here. But right now I want you to import another file in the snap1 folder on the desktop, snap1 folder, that is car.xml. So this program, what it will do is it will use some loops and if-else conditions. You will understand them in the next few weeks. But using that, what we will do is we will replace the arrow object using this car shape, and we can move it around the white patch. So if you see that, you see it will keep moving inside the white patch forever. So this is a very simple example of how we can use loops to move objects and create motion graphics. You will be able to understand it after 2 weeks how this program is working, but this is just now a sample of what other things you can do in Snap. So that's the end of this exercise, everyone. I will stop now. No, before I do that, wait, one more thing, that is how to submit. So how to submit this assignment. To submit this, make sure you have that folder snap1 minus your ID on the desktop. It should have these 4 files. You right click, send to compressed folder. Send to compressed folder. When you do that, it will make a zip file, and this zip file you will go to the Blackboard assignments, and there in the snap1 assignment you can browse your computer, you can attach this file snap1.zip, attach it and submit. So that is your snap1 exercise. So make sure you complete it before your next class and submit this.